Your company wants to print some flyers for advertising a new product. The printer has two options to produce the flyers. The traditional printing costs $250 for setup and $0.15 per page printed. To print the flyers digitally, they charge $50 for setup and $0.20 per page printed. Write equations for the cost to print N flyers using these two printing options. So we'll let N represent the number of flyers printed, and we will let T of N represent the cost in dollars for traditional printing, and we will let D of N be the cost in dollars for digital printing. So now let's write the equations for these. Traditional printing costs $250 for setup and $0.15 per page printed. So then T of N would be 250 plus 0.15 N. To print the flyers digitally, they charge $50 for setup and $0.20 per page. D of N would be 50 plus 0.20 N. Graph the two equations on the same calculator window. Alright, so we had that T of N was 250 plus 0.15 N, and D of N was 50 plus 0.20 N. Alright, so let me go to my calculator. Y equals, let's clear out some of the old stuff. Let's turn the plot off. Now, if you have the plot on, you want to turn it off. The easy way is to go to the Y equals screen, move up to the plot, and hit enter, and it'll toggle off. Alright, so my Y1 is 250 plus 0.15x, and my Y2 is 50 plus 0.20x. Now let's consider an appropriate window. N is the number of flyers printed. So we probably don't care about negative flyers. That doesn't make sense. So let's start with 0 and let's move up to, I don't know, some large value. So let's try 1000 for x. Now, all right, so let's have x going from, let's start it with 0 to 1000. Now, y, our outputs are dollars. So let's see $0, but we know that our first y-intercept is 250, so let's try 0 to 1000 as well and see what happens. Alright, so my window, let's go 0 to 1000 on the x, and I'll use a scale of hundreds, and we'll go 0 to 1000 on the y, and again a scale of 100s. Alright, so let's graph in that window, and we do see two lines. But now, we probably want to see a little bit more than this. We want to see where they intersect. So it looks like this, and since the slopes are different, it looks like they're going to intercept eventually to the right. So let's adjust the x maximum. Let me change it to 2000 and see if that does what we want. That's a little better. Let's go further. Let me change it to 4000. Alright, so we're graphing 4000. That's a little better. It looks like they're almost intersecting. Just go a little further. How about 6000? And while I'm here, let me change my x scale to 1000. All right, so there's a decent graph, and I can see a point of intersection. So let me go ahead and grab that. Put it down here. All right, so we ended up with a 6,000 instead of a 1,000 here. All right, find the number of flyers that will result in the same cost for both printing methods. That will happen at the point of intersection. So let me go ahead now. I have the graph. I see that the two lines intersect. Go into the Calculate menu, which is above the Trace key. So I'll hit second and the Trace key to bring up the Calculate menu, and I'm going to choose the fifth option, the Intersect command. So I move down to it and I press Enter. Now get in the habit. Move your cursor left or right as necessary. Get close to the point of intersection and hit Enter slowly 3 times. So the intersection occurs when x is 4,000 and y is 850. So the intersection occurs when x is 4,000 and y is 850. So that would mean that n is 4,000. When n is 4,000, then t of n is 850, and d of n is 850. So what that tells me is when printing 4,000 flyers, the cost is $850 using either method.